Hello everyone, and in this video I will show you guys how to make a generic object pool in C++, and I hope that you already know what object pool is because you wouldn't search it. So for those who don't know, basically it's an optimization technique to increase performance. So for example, if you have a projectile, your typical workflow is to spawn the projectile, and then if it hits something, you just destroy it. And the object pool solves that issue by just creating the projectile, and then we reuse it. When we, for example, hit the wall, we will reuse it, and thanks to that we save the memory because we don't need to allocate new memory and destroy every frame. We just allocate the memory, for example, at the start, and then we just reuse the allocated memory. So to showcase that, I created a simple example scene. So we have a player character, and above that player we'll have the cube that will spawn, and the cube will have the physics enabled, and I can just play the game. And as you can see, there's a lot of cubes, so let me just decrease the number for a second so you will see better. So we have a cubes, and they are just they just basically have the gravity enabled, and they spawn above the player. When they hit the ground, they will just destroy itself. So every frame we are just creating the cubes and just destroying them. So if I open the console and I will write stat FPS, it will show the number of FPS that we have currently in the level. And if you can see on the left side here, we have the actors loaded. So you can see that this number is changing constantly because we are just creating and destroying every frame. So that's bad. And let's increase the number to 20, for example. It will spawn 20 cubes every frame. So if I enable the game now, you can see that the FPS is drastically went down. It's around 23 FPS. I don't know if you can see that because it's quite small. And yeah, to solve this issue, we can make an object pool which will increase the performance, but it really depends on the case. So you need to basically debug it and just check for performance. But I have the second example here with the same setup. It's the same setup, but this time we will use the pooled cubes. So we won't create new cubes. We will create them at the beginning, and then we will stop creating them, and we will just reuse the ones that were inactive. So if I play the game right now, you can see at first it will be slow because it needs to create those cubes at first, because you can't like make cubes out of thin air. So it needs to create new cubes, but after a while it stops creating new cubes and it will reuse the ones that already existed. So if you can see on the left bottom left corner, you have the same amount of actors because we don't create new cubes anymore. It's the constant number, and yeah, that's good. And you can see also from the performance, from the FPS, performance increased by it's around 32 FPS, so it's quite a big increase. But as I said, it really depends on the game and on the use case, so you need to benchmark it. So yeah, let's start making the video. Alright, so we will start the tutorial right now. I'll go straight to the code because I think you already have your own project, so there's no need to make an example like at the beginning of the video. So we'll just start creating the script. So let's go to C++ classes, let's go to public section, and we will need to create two new class. First one will be an interface, so we will call it pullable. And this interface we will assign to the objects that we want to be pulled. It will have two functions for basically two callbacks. One callback will be at the beginning when we spawn it, and the second one will be when we return to pool. So think of it like the equivalent of begin play and destroy on destroyed from Unreal. So it's basically almost the same. After it finish adding the class, just click no. So we don't want to edit it now. We want to create one more class. So again, right click, new class. And this one, we will need to go to all classes and we will search for WorldSubsystem. And if you don't know what subsystem is, I'll link the video at the bottom of the video, such in the description, and you will see it's basically like very convenient class to access it from blueprints. So it's like almost like singleton. So you can access it everywhere and just call the functions easily. So we will call it pool subsystem, and we will also create it, and we need to wait. Okay, it finished. Now we click also no, and we can also open our IDE. So I use the rider, and let's search for it. We have pullable, which is the first one, and we also have pool subsystem, which is the second one. So I will start from the simpler one, which will be pullable. So let's go to the header file of it. So we will need two functions, as I said before, and small notice, I will split this video into two parts. We will create in the first part the basic object pool system that will work only for one type of actor, which is basically a actor, and in the second one we will expand it to support multiple classes, and also it will be generic, so we can pass any type of actor in and it will work. So first, let's make an interface. So as I said, I need two functions. So we'll need a function called onSpawn from pool. It will be a callback, as I said. We'll also need a function called onReturn to pool. So those two will be called when we spawn and when we return the object. So we want it to be U function, so we can expand it from the blueprints. So it will be blueprint native event, so it will have no definition here. So you can expand it. It actually can be called blueprint callable, I think. And we will give it a category, which will be pullable. And the same will be applied to on return to pool. So to expand on those functions, remember that when we have object pool, those objects are not destroyed. So you will have to manually take care of resetting the variables. So for example, if you have an enemy and you want to return it to pool, you need to manually disable the collisions, for example. You will have to manually hide the mesh, and when you spawn here, for example, when you spawn the object, you will need to re-enable the mesh and other stuff like collisions. And so that's the drawback of using the object pools instead of just destroying and creating, but you gain performance. So that's something. So that's the basic pullable. We only write in the header file. There's no need to write anything in CPP file. You can of course add default functionality here in the CPP file, but I find myself not using that, but you might. So let's go to the other one, which will be pool subsystem. So first we'll start from the header file, and I will start very simple. So I will start very simple, and the second part we will expand on it and make it more advanced. So we will start very simple. First, we need to create two functions which are equivalent of destroy actor and spawn from actor. So first one, to return an actor we want to spawn, we will call it spawn from pool, it will take in the T subclass of a actor. So this is like the prefab that we pass, the blueprint that we pass, and we want to spawn. We will call it pool class. We will pass in also the vector, which will be the position that we want to spawn our actor in, and also f rotator, which will be the rotation for our actor. And that's it. The second function will be void. We don't want to like get back anything. We want to return our actor, so we will call it return to pool. We will pass in a actor, which we want to return, and we will call it poolable. So it's the pooled object that we spawned, and now we want to return it. So we need new functions for those two. We will need to make them blueprint callable, so we can call them in blueprints, and we can give them a category of pool subsystem. The same applies to the second one. And last thing, we will need an array to store the objects that we created. So we know which one, which we created, which we spawned, and which are available to be reused. So we will have the array of A actors. We'll call it object pool. And for now, it's just one pool. But in the second part, we'll make a dictionary with different types, and each of those type will have their own T array. But for now, we have one T array to store every actor. So we need to mark it uProperty, which will basically make Unreal handle the memory management for us. So we don't need to worry to manage the memory. So that's it for the header. So right now, let's just create the definitions of those. I don't know if you can see the fonts. I think you can. So I will just mark those two. Control dot generate definitions by declaration is something I have in Rider. Visual Studio also have it, but I don't know what's the shortcut. You can just double click on it, right click, and you should have something like generate definition here. But if not, just write like I have here. All right, so we will start from the spawn from pool, which will be quite simple. So first we want to check if the actor that we passed implements the interface that we created, the pullable one, the pullable interface that we created. So we need to write if pool class get implements interface, and here we specify the interface that we want to check, uPullable static class. This line basically means that the actor that we passed, the prefab that we passed, implements the given interface. And there's a lot of ways to check if an actor implements an interface. But when I checked online, if I remembered correctly, this one also checks if the blueprints implements the interface, because there's some functions that only checks if the class implements interface in C++, but we also want to have the functionality to check the blueprints that inherit from the interface, from the blueprint side. So that's why we need to have this syntax. So we get the class from the pool class, and from that we can check the function implements interface, and we just pass in the uPullable, the interface that we want to check. Okay, so after we checked that our actor implements interface, we have two choices. So at the beginning, we don't have any actor in the object pool. So we need to spawn the actor first, and then we can start reusing it. But if there's an actor already in the object pool, we'll reuse it. So we have two cases. So another if here. So we are checking if object pool, which is our array, is empty, so, which means that there's no actors, no objects in the pool, so we need to create one. So right now we need to create one. We will have fActor spawn parameters, which are the parameters for spawning. So we will call it spawn params. I like to write params instead of parameters. And we access it, spawn params. Here we can change few stuff like spawn collision handling override, like the blueprint node you have in blueprints. So we want to set it to spawn actor collision handling method adjust if possible, but always spawn. That's the one I chose because I always want to spawn the the actor that I passed. So right now we need to access the get world, and there's a function called spawn actor, and here we pass in the pool class, which is the T subclass we want to spawn. We pass in the location, position. Did I call it position? Okay, I will call it location. So it's like Unreal location, and here also we will call it location. Location. Okay, we pass in location, then we pass in rotation, and we pass in spawn params, which are our spawn parameters. And it's red, and the reason why it's red, I think, is because we need to specify what kind of actor we want to spawn. So I think, yeah, here we need to specify the type of the actor that we want to spawn. So right now it's just an actor, so we need to store it in a variable. So there's a better, so I want my variable to be here, so I will just create an actor and we will fill it in. We will call it pooled actor, and we will initialize it to null pointer. So at the beginning there's no actor, and at the end we just want to return that actor at the end of the function. So here in the first case we will fill it, so I will call pooled actor, I will assign it pooled actor equals this, so we just spawn the actor. So that's the first case, and the second case means that we already have an object in the pool. So right now we just want to reuse it. So if the object pool is not empty, so which is the second case, we want to assign pooled actor to the top element of the array. So we access the array object pool, and we have the function called pop. So as you can see, it pops element from the array, and that's it. We also want to set the location and rotation for it, because as you remember, we need to set it manually. So we will access pooled actor, and we will set actor location and rotation. There's a function to set them both in the same call. So we will pass in location, we'll pass in rotation, and that's almost it. So we covered two cases. We covered the case when we already have an object in the pool, and we covered the case when we don't have an object in the pool. So right now, after we have it, we want to call the function that we created in pullable interface, because we want to notify our object that you've been spawned. So we need to access the interface, and this is how you call the function on the interface. So you just write the name of the interface, you give a double colon, and you call execute on spawn from pool, and here you pass the actor that inherits from that interface. So that's it. So that's the first method. Now let's go to the other one. So here we want to check first if our pullable, the actor that we passed in, implements the interface, because if not, it might be the case that someone just returned to pull the object that didn't inherit from the iPullable, and we call for it and we execute on return to pull function, then it will crash. So we need to make sure that the object that we passed in implements the interface. So basically the same, we just access the pullable class. So we access get class, and now we just check implements interface, and here we pass in the interface that we want to check against, which will be uPullable static class, and that's our first case. So here we already implemented the interface, so we can call the execute on return to pull. We'll pass in pullable, and then we want to add it back to our object pool. So we access our object pool and we just add our pullable. So that's the first case. And the other case, if someone passed the function, passed the object that didn't inherit from the pullable, we will just basically destroy it. So we will just destroy it like the Unreal way. We basically call the function destroy, and that should be it. I think that should be it. That should already work. So let's compile the code and let's see if it works. Okay, so our project compiled and we have the project here. And now let's just make a simple example scene. I will just go to my, let's go to the folders. We need to create a projectile first. So let's go to blueprints. Let's go to projectiles. I already have a function, I already have the folder for it. Right click, blueprint class. We will create actor. We'll call it projectile, BP projectile pulled. We'll just open it. Let's open it and let's see. Expand it. Go to viewport, add the cube. Okay, the cube, let's drag it as the default scene root. Let's scale it down to 0.4. Make sure to have this locked so it will change all the values. We'll want to have simulate physics on. That's the first thing. We will also want to have simulation generates hit events, which means that it will generate hit events because we want to destroy it when it hit the ground. And there's one more thing that I want to change. Here, if you go to collision preset, go to custom, click custom, and in camera, just click ignore. That's just for camera to not zoom in when the cube obstruct the view of the player. So go to event graph, click on the cube, scroll down and just select on component hit. It will have this function. This function will be called when it hits something. So we want to get our subsystem that we created. So we want to access pool subsystem. And if you write pool subsystem, you will have this function. And as you can see, it's an instance of our subsystem. And from here, we can write return to pool. And here we need to pass the pullable. So pullable, which is basically the actor that we want to return. So it's our self. So just write self, get reference to self and pass it in. And here just connect it. So right now, when it hits something, it will return back to our pool. And right now we need to create it to spawn. Someone needs to spawn it, so it will be player. But before that, we also need to assign the pullable interface that we created. So if you go to class settings, here under interfaces, you can add interface that you wanted to inherit from, and it will be pullable. And right now, when you compile, you will see on the left, my head is covering it, but on the left, under interfaces, you should have the functions for those two that we created. If you click on those both, they will just spawn here. So we have two callbacks. So right now we can just print string and we can print spawned from pool. That's the first print string, and the second one will say return to pool. So those two functions will be called, and now we need to spawn it. So let's go to our player. Alright, VP player, I have a player character. I think in the template there also should be, but you might already have it. You might already have your own character. So inside player character, I just want to delete those first. It's empty. I want to access the spacebar event. So access the spacebar event. I want it to spawn a cube every time I press the key. So we want to again access the pool subsystem. From pool subsystem, we want to spawn from pool, the function that we created. And here you basically just pass the things that you would normally pass in. So pool class would be projectile, BP projectile pooled. Location, we can pass in the location of our character. So I'll get actor location and I'll add, for example, 500, voice crack, 500 above the player. So we can pass it here and basically it should work. It should already work. So if I click play and I click space, as you can see, it found, but then it dropped. And as you can see, there's multiple logs because it didn't actually hide itself. So we need to, as I said, manually take care of it because now it does not destroy itself. So we need to make it invisible. So inside here, instead of logging, we can call the function called setActor hidden in game. So we will just connect that. We'll make it on return to pool. We want to make it hidden. Okay, so we want to make it hidden. So right now it will be hidden if I click play and press space. As you can see, when it hit, it becomes hidden. But we also need to take care of other stuff like disable the collision. So we can access set actor collision, enable collision, and we'll have it to false, I think, or we can actually access the cube, and here we have set collision enabled. So from this function, you can set to no collision. We also want to set simulate physics to false. So we don't want to simulate physics anymore, but actually we need to call this first because Unreal would give an error, a warning. So we don't want to simulate it and we don't want collision. So if I click play now, press space, it will hide itself, it will disable the collision and it will disable the simulation. So that's what we want. But if I click again the space bar, you can see there's a log spawned from pool, but you see no cube because it's hidden. So we also need to take care of that. So here, instead of logging, we'll just copy all of this and connect it and just reverse the order. So we want to not hide it, we want to simulate physics, and we want to set the collision to collision enabled. So right now, if I click play and I click space, you can see it found and it hide. And if I click space again, you can see on the left bottom corner there's still the same amount of actors. So we are not actually spawning new actors, we are just reusing the same actor. So yeah, that's the first step, and I think, yeah, we'll end the video here. Just a small notice, in the second video we'll fix a few stuff. For example, this set actor hidden in game could be moved to a script because I think it will be applicable to all the cases that you spawn. So this can be moved to a script. Maybe this can also be moved to a script, but we will see. And another thing to notice, you can see that every time we call return to pool, we need to get pool subsystem. So I will also address that in the next video, so we will get rid of it. But for the first part of the video, I think we are done. So I hope you enjoy it, I hope you learned something, and see you in the next video. So thank you and bye bye.